In this video, I'll see the test program for the pulse width modulation core. So in this particular test program, we define a few of the variables. What's interesting in this particular one, which we call P20, and if you take a look at the comment, that particular number is just the 20th root of number 20, which means like if you take this number and you multiply it or you take it to the power of 20, you're going to get 100, and you see why in a second. What this does, it actually controls the colored LED on the board, the one that you see in here. And actually this program is currently running on the board. What it really does first, it sets the pulse width modulation frequencies to 50 Hertz because we're dealing with LEDs. And then it goes for both LEDs, it actually goes through the 3 different channels on these LEDs. And these are basically the R, the G, and the B, which is the red, green, and blue channels. We do have 2 LEDs, and each one of them would need 3 different pulse width modulation to control the different colors. So in total, we're utilizing 6 pulse width modulations outputs in here. So first we'll set the red, and then we'll manipulate the green, and then we'll manipulate the blue. And what you see in this code is first we're going to start with M0 for the red, and we'll say that the brightness, we set it to number 1. And then in here, what we see is like we are going to iterate for over 20 cycles. And these in 20 cycles, we're going to be utilizing this 20. This is where the 20 comes from. So if you take a look at it, 1, and then you multiply by P20, and if you're doing that 20 times, eventually the brightness will go to the maximum number of 100. So the minimum number is actually 1 times that value, okay, which is 1.25 all the way to 100. And of course, because we're going to be utilizing that brightness, we're going to convert it to a duty cycle. And the way we do it is just we normalize it by dividing it to 100. So the maximum value it can take is 1, and the minimum value is 1.2 divided by 100, which is 0.001. It's not exactly 0, but it's close enough. And then we're going to take that number, we're going to set it as a duty cycle for the channel N, which is essentially at the very beginning is 0 and 3, basically for the first LED and the second LED. So channel 0 is for the first LED, channel 3 is for the second LED. If you just want to turn on one LED, you can just take off or take one of them out. We do wait for 100 milliseconds, and then we keep it. So effectively what we're doing is we're going from pretty much no brightness all the way to the maximum brightness for each of the colors. Or actually in here, what I just showed you is for the red. After it's done for the red, we just zero it out. We make sure that it's actually 0. There's no red whatsoever. And then we repeat for the green, we repeat for the blue. Okay. So that's basically it, and the program is running. So I just want to show you how the pulse width modulation is actually changing the duty cycle physically. And the pulse width modulation core has these 6 outputs connected to these LEDs, and it has an extra couple of outputs. If you go to Vivado and you go through the HDL code, and the constraint file, you will see that 2 of these signals are connected to the JA mod in here, specifically to number 3 and number 4. So we're gonna do this here just so that I show you the signals. So we set the duty and duty. So instead of writing to these channels of the LED, I'll just basically write to channel number 6, which is one of the 2 available. I can write to 6 or 7. I'm just going to write to 6 in here. We do that. You compile, and you compile it and you load it to the FPGA, which is actually currently running right now. So I want to just show you what's happening in here. So I'm showing you the output of this particular channel in here, the one from the P mod. And what you do see, it's actually going, it's not exactly 0. Okay, it goes for a little bit more, but remember that brightness is 0.001 all the way to approximately 100. I believe there's like some sort of sampling errors, or basically my scope might be just showing me not a perfect 100%. But you get the idea. The idea I want to show you is the color and the duty cycle are associated with each other. So you see the minimum brightness here, and then it goes all the way to maximum brightness. And I'm showing it to you on all the colors because I have included that in here so that it's not tied into a specific color.